One of the new changes to the C# language is the primary constructor. Now, there's been some confusion around this topic about why it exists, what purpose it serves, and how you'd use it for various scenarios. In this video, we're going to look at what primary constructors do and how we can use them safely and effectively. Now, before we dive in, I want to share a couple things with you. First, if you're interested in improving your C# skills, be sure to subscribe to this channel. With over 500 C# videos and counting, it's the perfect place to learn and grow your skills. Second, if you're looking for free C# resources, head on over to imtimcorey.com and check out the resources tab. There you'll find my podcast, my C# projects page, and much more. And finally, if you're ready to dive deeper into a specific topic, I have a variety of courses that can help. Not only will you receive a world-class education, but you'll also help me fund the free content so that everyone can have a great education in C#, not just those who can afford it. So let's dive right into what primary constructors are and how they work. Now, to do this, what we're going to do is create just a simple console project. We don't need anything complex here. We're just going to say primary constructor constructors, and we'll call it primary constructors demo. We'll hit next and .NET 8. Okay, so once this gets created, what we're going to do is create a few different examples with before and afters. So I'm going to create a new file. We're going to call this simple, which is the simple demo. We're not going to be necessarily running this application as much as demonstrating what these things do. So the difference here is that this isn't about creating an application that does something, but rather it shows off what we're learning here. Okay, let's clean it up a little bit and make this a public. We're going to call this simple before. Now, normally I name the class the same as the file name, but we're going to have a simple after as well. This is the before and after, before the primary constructor and after the primary constructor. So one example of a constructor might be that we're capturing the first and last name. So we're going to say CTR for constructor, and in here we're going to say let's capture string first name and string last name. Now, let's say we're not going to create properties for these. We're just going to create them as fields. So we're going to say, okay, I want to control dot here to create and assign a field for first name, and we'll do the same thing for last name. Okay, and notice it's already asking for primary constructor options, but let's ignore that for a minute. Now, maybe you don't want these read-only, so we'll just mark them as private, okay? So they're private strings, and we can come down, into a method and actually use them. So you can say something like public void test, like so, and ignore the suggestions from GitHub Copilot. It's not knowing what I want to do. But we could just say, actually, let's return a string. And let's just say full name. This is probably actually a property, but we'll call it a method. And we're going to say return, and we'll say first name plus last name. Okay, that would be how we work with these type of values, where we're passing in values to our constructor, meaning we're saying when you instantiate a class, you have to give me a first name and last name. And when you do, I'm going to store that somewhere so I can access that value somewhere else. Okay, so that's what we had from C#11 before. This is, pre.NET 8 release, pre-C# 12. Okay, so what does it look like now with our primary constructor? We can say public class simple after. Okay, so instead of having a constructor and passing in parameters, we're just going to copy this right here and put it down here. And we're done with all of this. Okay, in fact, we can copy this string full name, and there's no underscores. But there we go. This definition right here is the functional equivalent of this definition. It's a lot more compact. But what's happening? Well, what's happening is just like with records, records have this structure right here, right? So if we were to create a public record, simple record, we could say, whoops, wrong paste. We could do the same thing. Only we'd actually name them something else. We'd say string first name, string last name, like that. Okay, that's a record definition. And it's similar to what we're doing here, but it's not the same. Notice we are using capital F and capital L because in a record, these become properties. But in the, and we can comment this out now. In this, the primary constructor example here, these do not become properties. They become parameters that are passed into the constructor. So these parameters, though, are available throughout the entire scope of the class. So first name is available in the full name method. Same with last name, it's available in the full name method. So what we're doing is we're saying these are available internally. And we don't have to bring them into a constructor like this, because remember, if we bring them in here, they only last for the scope of the constructor. When the constructor is closed, you can't access underscore last name anymore. That doesn't work because this last name parameter only lasts for the scope of the constructor. Well, with primary constructors like this, they last for the entire scope of the class. They're available everywhere that you want to access them if you want to set it up that way. And we're going to talk about how to change that in a little bit. But this also means that these are mutable or changeable, meaning I could set the last name value. I could say last name equals test, and that would work, which also means if anywhere else in this class relied on that last name value, well, it's now been updated if you'd call this method first. So just note that they are changeable. That's why up here I kind of reflected that by saying private string first name, because these are also now changeable. Oops, I clicked on that link. So these are also changeable because they're not read-only. And we're going to talk about how to make it read-only because you cannot declare them right now. You cannot declare these as read-only. Now there's talk about in the next version of C#, C# 13, which would come out next year. So it would be coming out in November of 2024 with .NET 9. There's talk about maybe making these read-only, but how do they read-only? If they read-only, throughout the entire life, or how does that work? They're going to figure that out, okay? But for right now, there is no ability to mark them as read-only, meaning when they come in, they'll be read-write. So that's the primary constructor, and its job is to say, hey, you know what? We don't need to do all of this setup work when we can just declare and use them. Okay, so this is not a solution for every problem. And if you try and approach every single class by using a primary constructor, you'll probably create some problems. But there are instances where this makes sense. Now, I do want to point out that if you use a primary constructor, like we are doing right here, if you decide, hey, I want to have another constructor, maybe I want to have an empty constructor like this. Guess what? Right now it doesn't work. Well, why doesn't it work? Well, we must have an initializer for our primary constructor. And how do we do that? Well, we say this, and we pass in a first name and last name value. Maybe we pass in 2 empty strings. That would work. So, but every constructor has to call the primary constructor now. So it's no longer we have different options. We always have to call the primary constructor if we're using one. So if we have an empty constructor like so, then it has to call the primary constructor and pass in values for first and last name. And you could put in, test and value. Like you could put in whatever values you want, but you have to initialize these two variables because these variables will live throughout the entire lifespan of this class. And so you're putting something in to start them out. Now, it might make sense to make them empty strings or something like that. So you can have multiple constructors if you want, but you always have to pass in or call to the primary constructor using the this keyword and calling those parameters. Now, the question's going to come up, where do these live? Like, are they just private fields? Well, yes and no. They're kind of private fields, but not really private fields, meaning you can access them anywhere in any method. But if you were to try and say this dot first name, you wouldn't find it. It would error out and say, no, that's not available. So it's still a parameter, but yeah, it's kind of a private field. It's a little bit of magic they're doing behind the scenes. But just kind of know that it's, Microsoft is taking care of it for us. The .NET framework is taking care of it for us about where those are, but they do kind of exist. Now, what if you wanted to make them a private field with all the things available to a private field? Well, you could do that. You could say private string, and let's get the same exact name, first name. So private string first name equals first name. Okay. So now, if you notice, there's a slight shift here, but this first name is no longer being accessed when you say first name in any of the methods. It's going to be assigned to this field, and now this field is going to be accessed. So now we can say things like this dot first name, and that's available because it now is a true field. We've kind of elevated it to the field status. Now let's look at another example just to kind of bring out some more of what this means a little bit. So let's create a new file since this was kind of clogged up. Now we'll call this one props for properties. And we're going to, again, clean this file up so that it's a little more usable. Props before. And we're going to say, whoops. My goodness. Prop, string, first name, and last name. I'm going to take the sets off, so it only has getters. Now, you can still set a value through a constructor. So you can say constructor, and we'll say string first name, string last name, and I don't know if you know this, but you can also do control dot here and say initialize property first name, and then control dot here and say initialize property last name. Well, there we go. We've got this ability to initialize our properties. And this is before. We're not using primary constructors here. So how can we make this a little better? Well, we can do our after. So public class props after, and we're going to say this is the same signature line, and that's it. Okay. Now we can create those properties though. So we can create these same properties, but instead of having to have a constructor to assign the values, we can just say equals first name and equals last name. So they're initialized with the constructor. So just like up here, where we're initializing this get only property with an initial value from the constructor, we're doing the same exact thing down here by using the primary constructor. So that allows us to start things up properly for our class and in a much cleaner format. Instead of lines 3 through 13, 10 lines, we have lines 15 through 19. So we got 5 lines of text or 4 lines of text. So a lot cleaner. But I also want to point something else out. So let's just say I created a public void test method. Again, just as a demonstration. And I want to say console write line, and I'm going to access the first name value. So I'm going to say first name. And notice it doesn't show up in IntelliSense. Now, first name the property does, but not first name the parameter being passed into the constructor. So what if I just overrode it anyways and just did it? And that works, but now notice we have a green squiggly under our first name up here. And it says parameter string first name is captured into the state of the enclosing type, and its value is also used to initialize a field, property, or event. So what is this error message and why does it matter? Well, what it's saying is, hey, you captured the value right here and put it into this property, but then down here, you're not using that property. You're using again, the parameter. And maybe that's not what you intend to do, and it probably shouldn't be. If you're already capturing it somewhere else, you should use that other place for all of your usage. So in this case, we should probably be using the first name property in this test method, and then life is good. So this allows us to instantiate our properties, or set them up when they first get instantiated with a class, and it allows us to then kind of give some warnings when we try to use, again, this mutable value instead of maybe what we were intending to use, which was the value the property we assigned it to. So this, again, is how you could use your constructor parameters, your primary constructor to instantiate or set up your properties, and then make sure that you're using that throughout the rest of your code. Now, there's one we haven't gotten to yet, and that's read-only. This technically makes it read-only when we put into a property like this if we use that property everywhere, but we don't have to. We can say first name and just escape out and say test, and that would work. And that could cause some messy issues, but we don't want to do that. So how do we make this thing read-only? Well, there's some ways of doing that. And what we're going to do is look at that next. We look at setting up a dependency injection configuration. So let's call this from DI from dependency injection. Again, we'll clean up here, and we'll make this public. And we're going to say before. And here we're going to do is, it's really messing with me with the GitHub Copilot. Might want to turn that off. In fact, I'm going to do that. So let's disable. Okay. And it's still going to be IntelliCode, but it'll be a little bit less than having Copilot on as well. So what we're going to do now is we're going to create a prop, and a constructor. There we go. Constructor, and we're going to say we want to bring in iLogger of type from DI before. And we're going to call this logger. Now, we don't have logger installed in a class or a console application, so I do control dot here, and I want to install a package, Microsoft extensions.logging.abstractions. I'll do that, and then I will do control dot again to add that using directive. And there we go. Now we have logger. And with the logger, I'm going to do the control dot to create and assign a field called logger. Now, as you note, this is read-only, and that's a good thing because I don't want my values coming from dependency injection to read-write. I don't want to mark them that way. First of all, it's more efficient to make them read-only, but also it's the correct thing to do because of the fact that if I accidentally overwrote that value, that could cause a significant problem if it's, say, a shared value. So I definitely want to mark it as read-only. Well, how do you do that with our primary constructor? So public class from DI after, and we're going to say that I want to have this same logger, only I'll change the from DI after. It's on the same kind of logger, but how do I mark this as read-only? Because right now I could say public void test and say logger equals null, and that would work. Okay. Now it's saying here, yeah, it's not null here, trying to assign a null value, but it would work. Now, I don't want that. So what I want to do is mark this as read-only. Like I said before, there is not a way to mark them as read-only in the primary constructor. But that does not mean that you can't mark it as read-only anywhere. In fact, what we can do is say private read-only ilogger of type from di after, and call it logger equals logger. And notice I gave it the same name. So by giving the same name, I'm actually saying, no, whenever you use it anytime in this class, you're going to use the private read-only value. Notice down here, it's the read-only ilogger, and it's saying a read-only field cannot be assigned to. So you can't do this anymore. We've stopped you from being able to modify this logger. Now, we could have called this underscore logger like we would do up here, but then we could still technically do this because we're assigning it to the parameter, not to the newly created read-only field. So by naming the same thing, we're able to enforce that this is in fact read-only. So now, just to kind of clear things up a little bit, our class definition is like this if we were doing dependency injection versus like this, really. I mean, we can ignore this down here. So let's just get rid of it temporarily. So this is before, this is after, and they're the same exact thing. Okay, we've got the same exact setup. Now, that allows us to make things a little more clean and compact. The only thing you have to remember, again, is if we have another constructor, we have to call this primary constructor. But if you're using dependency injection, you probably don't have a different constructor that doesn't take in the dependency injection stuff. So you're still good. So that's how you'd use dependency injection and also ensure that you're marking things as read-only. And just, again, to make things a little bit easier, if we were to do control dot on this logger, there is create and assign a field. Now mine, again, starts with logger, and I just want to make sure that it's logger instead of underscore logger. But that allows us to use these tools very quickly and easily because we have those quick actions and refactoring. So yes, there's going to be a little bit of a change in how we do things with dependency injection if you're used to using the underscore for your private read-only fields, and having this change from underscore logger to logger, or logger to underscore logger. But now I recommend just giving the same name. That way you force people to use the read-only version as opposed to the read-write version. Now, this doesn't just work for what we have here. If we go back to our simple demo, I'm going to make some changes to the simple demo, but I could say, you know what? This private string first name equals first name, which we, again, overwrote. I could make this private read-only. And now first name is read-only. And again, notice down here, it's using the read-only string version, not the parameters being passed in. So this allows us to mark things as read-only if you want. And it allows us to say, hey, you know what? I want to initialize some properties. And yet, if we want to go really simple, we can just have this and just start using them. So if you don't mind the fact that they're changeable or mutable values, we can just say public class, the name of the class, and whatever values you want to bring in initially. Just, again, note that those values always have to be brought in then. Okay, so if you have other constructors, you have to start from the where you have the primary constructor, unless you then override it with passing in dummy values or sample values or something like that. So that is primary constructors and how they work. I think that, this does clean up the code quite a bit. And I think that there's a lot of, smart choices in here in how they work. And I'll probably be using these more throughout my code. However, I don't think that you have to use primary constructors. First of all, they're not for everything. For instance, there are times when you have a class that doesn't have a constructor that has parameters that takes in. For example, all of your models where you're passing, it's just a data model. You probably don't want to have a constructor that has no parameter or has some parameters. You might want to have an empty constructor, in which case you wouldn't want to have a primary constructor. Also, it does not hurt anything. For example, our dependency injection here. This syntax is just fine. It works the same way. It's just a matter of, do you want to do this more compact syntax? Are you okay with it? And are you okay with how it's set up? So what I wouldn't do is I wouldn't go around to all your existing classes and just change them over, because you might be introducing new problems or new issues. So instead what I'd do is moving forward, go ahead and use primary constructors, think about it. And if you're already working in a class, maybe you do switch it over to the primary constructor if it's cleaner, if it, makes things more readable. Remember, code's meant to be read by humans. So if it makes it more readable, great, and use it. And if it doesn't make it more readable, then don't do it. If it makes it more complex on the constructor side of things, then don't bother with it just because it's a new thing to do. Okay. And again, we talk about the idea of having, multiple constructors. And where was that constructor? A simple one? Having multiple constructors and having to, use this syntax, it might not work if you are, heavy on overloading constructors. So just, think it through, make sure that it makes sense for your scenario. But I think this is a great addition to the language as another option. People get kind of caught up in, well, there's, the right way of doing things. I don't think there is a right and a wrong way here. I think what it is another option for us. And options are great because they allow us to make choices and allow us to do what's best for our specific situation. And that's what this is allowing us to do, is make a choice that works a little better for some situations. Just like, the record is an amazing tool for certain circumstances. And when it works, it's awesome. And I would not change it for anything. I love this way the record's syntax works and how it's designed. And really, that's what we have now with the class. It's very similar to the record structure, only it's somewhat simplified, doing less things, but at the same time, it was more complex to implement, I think. So we've got this now in classes. We can use this to simplify how we do things for the creation of our classes. Just make sure that you understand why you're doing it and what it does. Okay, so that is the primary constructor in C#12. Now, if you want the code for this, there's a link down in the description. Thanks for watching, and as always, I am Tim Corey.